Hey guys, Mr. Gucci here, introducing to you polyatomic ions. Now, my period 5 and 7 class already got this lecture on Tuesday. You guys are familiar enough with polyatomic ions that you can just jump in and do this activity today for Independent Work Wednesday. Okay, this activity for Independent Work Wednesday is just helping you to become familiar with the polyatomic ions that you're going to be using throughout the course of the year. Okay, so periods 5 and 7 from yesterday, 5 and 7 from yesterday, y'all can just skip this and get right to work. Periods 1 and 3, however, you guys need to watch this video for a brief introduction on polyatomic ions, because we're going to start working with this stuff on Thursday and continue with it on Monday. Okay, let's get to it. So what are polyatomic ions? Now, polyatomic ions are ions made of a few atoms that are bonded together, like a molecule. Essentially, polyatomic ions are molecules that are only stable if they can steal a few electrons. In one case, give up an electron, okay? There's no easy way to remember the formulas and charges of polyatomic ions. It's not like that nice convenient chart I gave you for monoatomic ions that just shows you, oh, everything in this column is +1. Everything in this column is -2. You don't have that, okay? Previous years had to memorize the list of polyatomic ions and their charges. This year, you're not doing that. I'm not making you memorize it, but I still want you to become familiar with these polyatomic ions. Now, these polyatomic ions, they are molecules that have charges. And in ionic compounds, they act just like other ions, So like you've been doing some crisscrossing, you've been combining to cancel charges, you'll be combining and canceling charges with these polyatomic ions as well, but you still need a bit of familiarity with them. Okay, so here's an example of a polyatomic ion. So SO4. In our last chapter on covalent compounds, we would have called this thing sulfur tetraoxide. But if I told you to try and do the Lewis dot structure for sulfur tetraoxide, you would find that you could not. You could not connect all the dots to make things work. But if you were able to insert 2 extra dots representing 2 stolen electrons, all of a sudden you can do sulfur tetraoxide. So sulfur tetraoxide exists as a molecule, but only if it can steal 2 electrons. And when it does, we give it a new name. We call it sulfate. Okay, and there are a lot of polyatomic ions out there. Here's carbonate. If I told you to do the Lewis dot structure for carbon trioxide, well, you know carbon dioxide and carbon monoxide. Carbon trioxide would be impossible to do unless you could get your hands on 2 extra electrons. And that's exactly what happens. Carbon trioxide exists by stealing 2 electrons and becoming a negative polyatomic ion called carbonate. It's made of a carbon and 3 oxygens, but it acts like a single ion. It acts just like any other -2 ion would. It acts like an oxide. It acts like a sulfide, okay? It bonds ionically in exactly the same way, except it is polyatomic. It's made of several atoms working together. Here's phosphite, phosphorus trioxide, another impossible molecule to make using Lewis dots unless you could find your way to steal 3 electrons. And if you can steal 3 electrons, you can make it work. Okay, and that's what phosphite is. So there are dozens of these polyatomic ions, small molecules that work together to steal electrons and act like an ion. Okay, now remember, there's 2 parts to this. Okay, the formula part, which encompasses the atoms and the number of each that are present, and then you got the charge in the upper corner. So the upper corner is the charge, the bottom number, the subscript, is how many of each atom are present. Don't confuse these. Now, here are the 5 most common polyatomic ions. Okay, nitrate is NO3. It's nitrogen trioxide, which is only stable when it can steal an electron. Carbonate, which is CO3, 2-. All right, chlorate, ClO3, 1-. Again, this would be called the chlorine trioxide, but if you tried to do the Lewis dot structure, it would not work unless you could steal 1 electrons. Okay? Sulfate, SO4, 2 minus. These are some of the most common ones. Okay? Some of the most common ones. But these are not certainly all of them, or even most of them. In fact, you have a list attached to this assignment with the names, formulas, and charges of the most common polyatomic ions. You'll see most of them end in the word end in ate or an ite. A few of them end in ide. One of them ends in ium, ammonium, all right, which is NH4 with a 1 plus charge. If I told you to give me the Lewis dot structure for nitrogen tetrahydride, you would not be able to do it unless you could get rid of one of the dots. If you could erase one of the dots in the Lewis dot structure, all of a sudden the whole thing works. That is the only polyatomic ion that is positive. The rest are all negative and act like negative ions. So your activity today is to just become familiar with this list. Other classes are making the students write out flashcards on paper. I'm not asking you to do that. I have this polyatomic ion Quizlet that I just uploaded. And I want you to do a few things. I want you to run through the flashcards here, okay? Run through the flashcards. Try and become familiar with the names of these polyatomics. What is NO3 with a 1 minus charge? Well, that is, let's see here, that is nitrate. All right, great. How about NO2 with a 1 minus charge? That's nitrite. Okay. What is the so CO3 with a 2 minus charge? That's carbonate. All right, great. Okay. How about this? How about hydrogen carbonate? That's HCO3 with a 1 minus charge, okay? And so forth. So just become familiar with this, okay? I can't really access everything here. It won't let me do it. So I want you to do a few activities here, okay? I want you to do a few activities. You're going to do the flashcard. You're going to do writing. You're going to do writing or testing. You choose, write or test. And you're going to do the matching game to become familiar with these polyatomic ions. Now, this by no means is all the work we're going to do with this. There will be more to it, but this is what you're going to focus on today. Good luck, everyone. Please email me with questions. All right? Good luck.